So good evening, everyone. Today we'll be learning about topoSet and setFields. So we will look more in depth towards topoSet and topoSet dict and how to set up the case using topoSet. And you will also have an assignment on topoSet. And then we will move ahead with setFields. Setfields more is widely used in multi-phase simulations. So you will learn multi-phase in the next class. So I'm just setting up the building blocks for the next class. Okay. So again, we are familiar with an open form case structure. You have zero constraint system. Now, when you're dealing with a topoSet and set fields, you will have additional files in your system folder. Okay. So for set fields, you have the set fields dict. As I said, this is widely used in multi-phase simulations. So in this particular dictionary, you will be initializing all your values for your multi-phase simulation. In this, you will select a set of zones or cells, and you will basically um, mention in those cells how are they supposed to behave, whether they're supposed to behave as a water or air or any type of fluid that you want. Okay, so that can be done in set fields dict. Then we have topoSet, that is in simple terms topological set. So in this, you manipulate cells and faces to create a geometry, or based on your geometry, you can also create or you can manipulate these cells and faces to to make a geometry in simple terms. So you can in simple terms make geometries using the internal cells and internal faces of your volume. So that way you can do it using topoSet dict. And when you're working with topoSet, now I mentioned that you will have to manipulate the internal cells or the faces that are within your geometry or domain. So in that case, you would have to also specify a patch for it so that you are able to apply some boundary conditions onto it. For that, we have the create patch dict. So this file also we'll briefly look upon once we are done with topoSet. So in this, you can create patches to the selected phase zones that you are specifying using topoSet. Okay. Now, so before going to the dictionary, we will first understand what exactly is topoSet. Okay. So say we have this particular geometry. Okay, it's a rectangle and it's a circle. Now in this geometry, I want to find the area of the blue region. Okay. So if I were to ask any of you that how will you find the area of the blue region, you will clearly say that it's area of the rectangle minus area of the circle, right? So, so even if this was a 3D geometry, you will just have area of a cube minus area of a cylinder. Now, how do we apply this in open form or in the topoSet dict? So this is just a practical example of how exactly is the dictionary set up. So for the rectangular part, first you will define the rectangular area. So over here you will have some additional, you'll have some keywords, name, type, action, source. So we'll look at each of those in the meantime. So the very first thing is we are giving it a name, say area, and we are using the box to cell. Now box to cell is similar to how we've been using in Snappy Hex. You use a bounding box. So in this case, we have a rectangular area, so we're using a bounding box. Okay. And within that bounding box, you specify your lower limits, higher limits. Okay. So this is a way to define your rectangular area. So once you've defined the rectangular area, now you want to define the circular area or the cylindrical area. So in this case, again, we're keeping the same name area, and over here you have type and action. But under action, if you notice, over here we've mentioned it as delete. So we want to delete eh, the area that is used by the circular area or the cylindrical part. And in this case, you will see that in the previous one, we're using box to cell. In this one, we're using cylinder to cell. And the syntax for applying a cylinder a bounding box is a bit different. You have to specify some points. So you have to specify initial point, your ending point, and you'll have to specify the radius. The radius is r. Okay. So we'll look at this in the meantime. Okay. And finally, once you so again, as I said, over here you're deleting this circular area. So that's why we're using the action delete. And once you're done, you've mentioned or you've defined the rectangular area, and then you've defined your cylindrical area, and you want to delete that cylindrical area. Now, once you've done both of these, you will want to create a zone or a region. So in this, we are specifying everything that is within those two. The previous two parts, we specified the cells. Okay, we are mentioning the cells within that particular bounding box or that cylindrical area. Now in the cell zone part, we will combine both of those cells that or you can say a group of cells into a cell zone, and we're defining it as a zone. So this is what your cell zone does. So in this case, we are using the source info, we're using set the area. So both of those blocks, you can say, were labeled as area. So it will access the data that was set under area. So you had area of a rectangle and then area of of circle or cylinder, and then you wanted to delete that. Okay. So in this way, this particular syntax, when you specify a zone, it will access all of those blocks that you've previously mentioned within the source info. Okay. But this is just an operational example that I've given. We'll look in detail about how to set each of these up. Okay. Now, when you're looking at the syntax, you will have two key things that you have to keep in mind. You will have type, that is a type of set. Within this, you will specify your set, and then you have a type of source. Okay. Now, a set, these are some of the existing sets or sources you can use. So a set is, in simple terms, you are specifying a group of cells. Okay, so it can be a cell or a face or anything. So over here, the set, under set, you have cell set. So cell set, it is basically setting or collecting all the cells that you define within a bounding box, for example. Okay. So if you're using the type set for type set, you're using cell set, it is accumulating all of these cells. Whereas if you're using the type cell zone, it's accumulating all the zones that you're specifying. Face set is, it will not use all the cells or the volume of your cell, but it will rather take a face. Now that also, it depends on how far are you from the centroid. We'll look at that also. Then the next thing is your source. So your source is anything that comes before your source info. Okay. So it can be cylinder to cell, it can be cylinder annulus to cell, it can be box to cell. There are multiple options. Okay. So these are the two key factors that you have to keep in mind when you're working with topoSet. Okay. You have set and you have source. Now, for this particular case, we have one geometry. So it is a simple heat exchanger. We have over here, we have two cold pipes. So we have the cold region in blue, and around it or surrounding that cold region, we have a pipe that is solid 1, solid 2. Okay. And these two pipes are within a domain. That domain is filled with hot fluid, and this is your hot inlet and this is your hot outlet. Okay. So these are faces, these two in light blue. The one in red, that is this entire domain, which is 1 meter in length in the z direction, and there are some more dimensions as well. So this particular domain is your hot region, and in blue you have that is your cold region, and everything around the between the blue and the red region is your pipe, or you can say solid. And along with that, we are also going to be specifying around this entire hot domain, we want to specify your container walls. Okay, so we'll be specifying a face container walls. You will have in total 1, 2, 3, 4, 5, 6. Okay, you'll have 6 faces. So we are going to do this using topoSet only. Okay, so this is a good example because it uses most of the features that topoSet has to offer. So if you're able to do this properly, you are well versed in topoSet, I can say. Okay. So again, over here I've jotted down all of the zones or the regions that we'll be using. Okay, so you have hot, cold 1, cold 2, that is for left and right, solid 1, solid 2, hot inlet, hot outlet. Okay. Now for the assignment, you will have to refer to this PPT, and you'll have to refer to this slide in particular, because in this particular slide you have all of your XYZ coordinate systems. Okay. And you'll also have the bounding box. So as I said, this particular domain or your hot region is the bounding box itself. Okay. So it ranges from this particular point up to a point in the Z direction. Okay. So again, you can use all of these points. They will be essential when you're specifying it in topoSet. Okay. So, okay, before going to this, I'll first show you what exactly we're trying to do. So I have the case run. I haven't done the faces for the container wall. It's fine. Okay. So this particular case is for OpenFOAM 9. I'll just run it because I already have done topoSet. Okay. Yeah. So I'll just switch off everything that was previously. They will only keep the internal field. Okay. Okay. So this is your geometry. Okay. So first you would have to create your domain or your geometry using block mesh. So in this case, we have created a very simple block mesh file. And from that block mesh file, we have created a simple cube or a rectangular cube. Okay. So you can see the mesh. So around the pipe areas, we have already defined a finer mesh because we require a finer mesh when we are modeling the solid pipe. And also we'll require a good enough mesh for the cold region. Whereas for the hot region, it's fairly coarse. Okay. Yeah. So this is the geometry. So what we are trying to do is first we will define the cold regions. Okay. So again, I'll just close this. So I'll say cold 1 and cold 2. Okay. So this is just your cold region. Okay. That is the inner cylinder. Right. I'll switch access on. Okay. Yeah. Okay. So we are first going to define. I'll only show you how to do for one. You will have to replicate it for the second case, for the second part, for the second pipe. So it's fairly simple. Okay, you can refer to the same PPT again. In that, all the syntaxes and all the necessary files are there. All the necessary um, XYZ coordinate systems are there. Okay. So first we'll define the cold region. So this is your pipe. So it's going to be a uh, complete zone within it. And the next thing we will do is we will define the cold pipe. Okay. So I'll switch the cold region off and I'll switch on the cold pipe. Okay. That is the volume that is surrounding the cold region. Okay, so it is going to be hollow in the center. That is why we are using the annulus keyword. So annulus is just a ring-shaped object. So in this case, we are going to be using the annulus keyword for this. And once we are done with specifying the cold region and the cold pipe region, we will then specify the hot region. Okay, so hot is under this one. So the hot region will be all the entire domain, but without the volume of where the pipes are. Okay, so where your cold pipe is, we'll be omitting that particular part out. Okay, so we'll be using that delete command again. Okay, and again we have hot inlet and hot outlet. So these are on the top and bottom. Yeah. So this one, this is your hot inlet and this is your hot outlet. Okay, so these are faces. We'll be mentioning these faces using topoSet as well. Okay. So this is the general idea of what we're trying to do using topoSet. Okay. Okay. So coming back to the PPT. So as I said, first you will create your mesh or your domain using block mesh. And within that domain, you will be manipulating the cells based on how you want it to behave and what you want to assign to it. Okay. So the left one is your domain. The right one is your mesh domain in 3D. This is the XY plane. Okay. So we'll be referring to this majority of the times. So we'll have the domain in the XY and this with the mesh. Okay, so just keep in mind where exactly are the pipe zones and the pipe regions, pipe and the cold region. Okay, so the very first thing we'll do is we'll define the cold region. Okay, so in this case, I'm defining the left cold region, that will be cold one. So we'll name it as cold one and we will define this term as C0. So as you saw in the example, we had defined one term as area, and then while labeling it, we labeled it as my rectangular area, but it was accessing all the data that was stored in that area. So similarly, we will name this particular this zone or region as cold one, but we will specify it using the term C0. Okay. Okay, so there are two parts when you're working with topoSet. First, you have to define a region, and the next thing is you have to name that region. Okay, so to define a region, this is your syntax. So I can also open the toposet file so that you better understand it. So this is your toposet. Yeah. So over here you have actions, and over here you will specify your zones or the regions that you want. Then you will name those regions and so on and so forth. You can also name your faces. You can also define faces, all of that. Okay. Okay. So first we will define this code region. Okay. So the very first line that you have in this syntax is your name. Over here, you will specify whatever name you want to specify to your region. Okay. So I can label now over here, I will label it as C0, but you can label it as C1, C2, C3, or your name as well, your friend's name. You can add your favorite fruit or anything. So the name is irrespective of that, but just remember that whatever name you specify under the definition part, the same name has to be used when you're using or when you're naming a particular face, because it has to access this particular syntax. Okay, so over here we've named it as C0. Then the next thing we have is the type. So again, over here we have the type of set. We spoke about I spoke about what was the set and what is the source. So over here we are using the cell set type. In this we are defining all the cells within this volume, or we're selecting all of the cells within this particular volume. So again, we are setting the cells up. Okay. The next thing we have is action. So in the action, we have written it as new because we are defining a new region. Okay. So if you were to define, say, another region and you want to merge both of them, you can also use the action add. If you want to subtract something out, you can use the action subtract. You can use delete. So there are multiple options. Okay. I've I've put a link at the end of the PPT so you can access the documentation that is there for toposet. In that they have mentioned what are the available actions that you can use. Okay, so over here we're defining a new region, so we have defined the action as new. Then we have the source. Now the source is again the type of source that you will specify and the selection that you will require for it. Okay, so in this we want to specify a cylindrical area or a cylindrical volume. So in this case we are using the cylinder to cell keyword or source type. Again, whenever you're specifying any of these source types, you will have to specify a lower and upper limit. So again, those data will be fed into the source info part. Okay, so over here, as I said, your source info part will contain all of your lower upper limit. If you're using a cylinder, then it will also require you to add a radius. If you're using annulus, it will have some additional parameters. We'll see that in a while. Okay. So under the source info, the very first thing you have is P1, and over here we set it to 0. Now P1 will be your starting point, okay? Or you can say a lower limit. So over here you can specify a coordinate in your XYZ coordinate system. Now in our case, if you refer to the previous slides, you will see that cylinder, your code region 1 is set at the coordinate system 0. Okay, it's in coordinate system 0, and your next point will be in the z direction at a distance of 1. Okay, so that's why your starting point is at a coordinate system 0 or at the origin, whereas p2 will be your end point or your second point, or you can say upper limit. In this case it is at a distance of 1 in the z direction. Okay, once you've specified your lower and upper limit, you have to specify your radius. So under radius you can specify the radius that you're using for a cylinder. In our case it's 0.011. Now, since we're using the cylinder to cell source type, we have to specify P1, P2, and radius. Depending on what type again you choose, these things will vary. Okay. Now, once you have defined your cold region, okay, now we want to name this cold region. So again, over here you have another syntax then for naming something. So for name, we will label it as cold one. So again, over here you can label it as anything you want. Just remember that whatever names you put over here, you can use those to create a patch as well. So if you're specifying something, you just remember it so that you can put it into your create patch fields dict. Okay, create patch dict. Then again we come to the type, that is your cell zone type. Over here you will specify the type of set, okay, your type of set you're using. And again, this will select all the cells that are within your mentioned volume and it will assign it as a zone. So in simple terms, you're grouping that cells that are there within this particular or the mentioned source info or the set type, and you're just going to group all of those cells under one designated name cold one. So anything within all the cells that are selected within that zone will all be defined cold one. Okay, so that is your cell zone type. Under action, again, since we are creating a new zone, we are using the action new. Again, over here you can use different. You can use delete as well. So again, there are multiple options for that. And under your source type, you will specify again your source type that you want to specify, and this will use or this will select your cells using the parameters defined under source info. So again, for source type, you're specifying set to cell zone. Now this will access your set, that is set is C0. Now in the previous syntax, you saw that we had labeled it as C0. So it will access all the data under that block, and it will define, say that all the sets within that cylindrical volume, it has to be set under cold ones. That info it gets from here. Okay. So in this way, both of these are related. You have to first mention your cold region, or you have to define your region, and then you have to name that region. Okay, so that naming part, you can use it to create a patch that you can later on manipulate or put some boundary conditions onto it. Okay, now we've assigned the cold region. Now we want to define the cold pipe region. Okay, so again, over here we will define that term as C1, and we will name this particular region as cold pipe 1. Okay, so again, we have the similar syntax. You have name type action, so those will remain same. The only difference is that over here under name, we are changing it from C0 to C1. Again, over here you can change it to anything else you want. The key difference that you will see between the cold region and the cold pipe region is that over here we are using the cylinder annulus to cell source type. So again, as I said, your annulus is just a ring shaped object. So over here, you'll have to specify some additional info in your source info. So again, since we're using the cylinder annulus to cell type, we will have the starting point. So you will have your lower limit. In this case, it is again at your origin. Then you have your end point, or you can have your upper limit. This is again at a distance of 1 in the z direction. Then since you have a ring shaped object, it will have an outer radius and an inner radius. So you have to specify both of these within this block or within this particular syntax. Okay, so you will have your outer radius where you will specify your outer radius of your cylinder, and then you'll have the inner radius. You'll specify the inner radius of a cylinder. Now once you've defined your pipe region, you will now name that pipe region similar to the cold region. Okay, so again, over here you can label it as cold pipe 1, or you can label it as anything you want. You can even label it as solid 1, solid 2, depending on whatever you choose. Okay, so the naming, again, this name can be used in your create patch in your create patch dict to manipulate or to put any boundary conditions if you want. Then again, type and action are the same. You are using the cell zone set type, and you're using action new to create a new region or a new zone. Again, over here, you're using the source set to cell zone, and it will again access all the data that you have set under C1. So since we are using the annulus type, it will get that info using the syntax block that we had set for C1. So over here, then it will know that we are trying to assign a region or name this particular region, which is a cylinder annulus or a hollow cylinder. Okay. Now, so for now, we've defined the cold region and the cold pipe region. Okay, so the cold region was inside this, and then we had the cold pipe region. Now you have to do the exact same thing for the second pipe. Okay, the second pipe and second cold region. So this one we had labeled it as C0, C1. So C0 for cold region and C1 for the pipe region. So similarly, you can also assign it, say C3, C4 if you want, or you can label it as anything you want. Okay, so I've done this for one part. You will have to do this for both, and then we will define the hot region. Okay, because the hot region will require the entire domain to engulf the entire domain, but we want to also separate the cold regions, both of these pipes. So you will have cold region 1, cold region 2. So we want to separate that. So again, over here, first we will define a term called C2. Then we will name that term or that region as hot region. So again, we'll do the naming. And since we want to delete the existing part, that is of the cold cylinder and the cold and or the cold cylinder and the cold region part, we will be deleting that region. So we have to delete that as well. Okay. So first, we will define that hot region. Again, you can use the naming C2. And again, the first three are the same. You have name C2, then you're specifying a type cell set because we're setting up the cells. Then we are also using the action new because we are defining a new region. Okay. Now over here under the source type, we are using the box to cell. Okay, because we want to define a bounding box or a cubical area or volume. So under source type, we will use the box to cell. Again, under box to cell, you'll have to specify some lower and upper limits. So that can be done using the source info. So under the box keyword, you can use box. That will be a specific keyword. And then you will specify your lower limit. In this case, it is -1, -10. And then you will specify your upper limit, that is 111. Okay. Now, if you are using the bounding box or this box to cell and you want to engulf the entire domain, okay, so you can go beyond the specified limit or beyond the specified uh, bounding or the boundaries that you have already set using block mesh. Okay, so say if my geometry was only up to say 0.9, so I can still use -1, so I can go beyond that point as well. It toposet will understand, open formula also understand that you have to engulf that entire geometry and it will assign it accordingly. Okay, it's only when you are doing something that requires it to be smaller than your geometry, that is when your bounding box or the limits that you set for this box, it will be very sensitive. Okay, so now we have assigned or we have defined that hot region. Okay, now this hot region was engulfing the entire domain along with the cold and the cold region and the pipe region. Okay, now we want to delete that cold region and that pipe region. So again, over here the same name we are using, name C2, again type cell set, and under action, this is where you will specify delete because we want to remove any cells that are within this particular area or this particular volume that we're specifying over here. Okay, so again under source step we're using the cylinder to cell because we want to take into consideration the cold region along with the pipe region. Okay, so we'll have both of the regions, so we'll just use cylinder to cell. Okay, and under source info you will now use, for radius you will use the annulus radius. Okay, because you want to take both of these, you want to take the cold region also and you want to take the cold pipe region also, so you will use the radius of the annulus region. Okay, so keep that in mind, otherwise you might only take the radius of the cold region and you might forget the annulus part or the pipe area, the pipe volume, and toposet might give you an error saying that there are cells overlapping and you've not assigned anything to it. Okay, so keep that in mind when you're dealing with such cases. So now we have specified that. So again, you can do this for the next or the second region that we have, the second cold region and the cold pipe region. So you can do the exact same thing for that as well. You just have to change the values of P1, P2. The radius remains the same, and all of the other parameters also remain the same. Okay. Okay. Now, once you've done specifying or defining and defining the cold region, the cold pipe region, the hot region, and then you're deleting all the cold regions that you have specified within that hot region. Okay. So now you will name that hot region. So over here we want to name it as hot. So again, you can use the name hot or you can use anything you want. You can name it as hot region if you want. Then over here, again, type you will use cell zone set because we are assigning all the cells within that particular zone. So we're using the cell zone set. Then again, action we are using new because we are defining a whole new region. And source types we're setting up the cells. You're using set to cell zone because we're going to we're going to access all the information set within C2. So now in C2 you will have two blocks. One is the block in which you had mentioned only the hot region, that is with your bounding box or your box to cell, and the second C2 block or your second C2 syntax block would be the one in which you are deleting out the cylindrical area for both the pipes. Okay, so again, topoSet will just do that when you set over your set C2. That is why it is crucial to keep both of those region names same, because then it will know that in one particular syntax you want to add a box and you also want to subtract something out of that box. Okay. Now, once you're done with the cold region, the hot region, now you will specify the inlet region. Now I'll just show you for inlet. For outlet, you can do the exact same thing. So again, we will define this hot inlet region as a term C5 and we will name it as hot inlet. Okay. So first we'll define that name C5, and over here, since we are using or we're defining only a face, we are not defining a volume, we will use the type. Okay, we will use the type face set. Okay, so this will select all the cells, uh, but this will only select or will set your selected cells to a face. Okay, again, I will explain how exactly it takes a face rather than the volume or the whole volume of your cell of your cells. That there's a reasoning behind that as well. Okay, so for now we are using the type face set over here. Okay, because we want to define it as a face. Action is again new because we are defining a new region or a new face. And over here under the source type, instead of using box to cell, we will use box to face. Okay, you saw that in the source type that I listed out previously in the table. So over here we're going to use the box to face type. Again, over here when you're using the source, it will access the source info. So for the box, you will have to specify your lower and upper limit. So that again, you can use the same syntax for box and then you specify your lower and upper limit. So this is your lower limit and this is the upper limit. So if you notice over here, for now, since it was on the top plane, okay, so your depth will vary in the y direction. Okay, so I'll show it to you. Yep. So see, it's in your y-axis. So your depth will vary in the y-axis. Now, since we want to specify a face, this will be extremely crucial. So if you notice the bounding box coordinates, so we have some coordinates in the x and in the z direction. So those are changing, so that's fine. But if you notice in the y direction, in terms of depth, we are specifying the depth very, very small. So it's 0.0001. Okay, so that's the difference, or 0.6 you can say. So that's the difference in the depth. So again, this is crucial. So for this, you will have to also know how much is your cell size or the approximate cell size in a particular area where you want to define a face, because again, that will play a crucial role. I'll explain that in a few minutes. Okay. Okay, so you've defined your hot inlet region, and now you will name that hot inlet region. Okay, so again, you can name it as hot inlet or anything you want. Type, instead of using the cell zone set type or the set cell zones type, you will use the face zone set, because we are setting up a face zone over here now. Okay, again, action new because we are specifying a new face, and source set to face zone, not set to cell zone. Okay, so there are a few differences when you're specifying a cell or a volume and when you're specifying a face. Okay, again, source info, it will access everything that you have set under the name C5. So again, if you've labeled it as say C4, C3, you can use that keyword over here. It will access that syntax blocks and everything that you have specified within that. Okay, again, you can do the exact same thing for your container walls. So again, I've not done that. I expect you to do that as an assignment. So for the face walls, again, you will have to specify, or you can directly name that face wall. So you can specify under source info, you can, or you don't have to actually name them. You can also name your region as whatever you want to name it in your create patch. So you can do that as well when you're working with faces. Okay, so you can put, again, you can label your container walls. So you'll have your front, back, top, bottom, left, right, and then you will also delete all the patches or all the areas where the pipes are located for the faces. Okay, so at your front and back you will have that particular region where the pipes are there. So that part you can delete it out. Also when you're dealing with the hot inlet and hot outlet part, so you can delete that particular area out of the face. Okay, now, when speaking about defining a face, okay, so again, as I said, it's really crucial when you are dealing with faces or defining a face. So say we have a cell, So this is a single cell in your entire domain, and you have your cell centroid. Okay. So now this is a 3D cell. Okay. So say you have a 3D cell, and this in blue is my face that I'm defining. So I want to define, say, on this left hand side over here, I want to define this face. Now, when you're defining this face, you have to make sure that this face does not cross your cell centroid, because if it crosses your cell centroid, it will start taking it as a volume and it might take the entire cell. So sometimes it may give you an error, but sometimes it may not. So again, it depends on very sometimes even I don't know exactly when exactly it does that. But again, you have to keep this in mind when you're defining a face. So make sure that it does not cross that cell centroid. For that, you'll have to know the approximate size of your cell so that you don't cross. So that is, so a good practice is to label a face in whichever depth you are. Now in our case, the depth is along the x-axis. So if I were to specify a face in my YZ plane, I would give a depth very small in the x direction. So say my cell was say 1 meter in size, I would define it at say 0.1 meter. Okay, so it's not crossing the cell centroid. Okay, so okay, make sure that the cell your face depth does not cross the cell centroid. Okay, okay. Now this was about toposet. Okay, so toposet and set fields are similar. It's just that their applications are a bit different. So you would use toposet to create a geometry a or a mesh in this case for a particular geometry, and you can manipulate your volume or your cells within your geometry. Okay, so say you want to do something as a porous media or something like that. You want to do some simulations regarding I want to find the porosity of a cylinder, a porous cylinder. So you can do that using toposet. Okay, so this particular case file, I'll share it with you. So under this case, you will have again your zero constraint system, but we are more interested in learning toposet today. So you will have to open the toposet dict. Okay. Now under the toposet dict, I haven't written anything within it. So this is what your assignment will be. You have to understand first what exactly is going on in toposet. You have to select an appropriate type action source depending on what region or what zone you are going to specify, and based on that, then you have to create the entire geometry that I've specified in the PPT. So again, all the coordinate system and all the coordinates that are required for making this particular mm, for making this particular geometry is mentioned in the PPT, so you can check that slide. Okay, so again, over here I've given the syntax for the very first thing. So if you have for cold region, you can again copy it off the PPT that I've already shared, the PPT slides that are already there in the syntax that is already there in the PPT. So you can copy it off for the first part. So you'll have cold and the cold zone, your zone type that you will specify cold region. Similarly, you'll have to do it for your solid. So in this case, it's solid one. So you'll have your solid pipe, and also you will have to specify the zone for it. Then you specify your hot. You will delete the area or the volume that is used by the cylinders. Then you will specify or you will name that particular volume or that particular region. Then again for cold pipe 2, for solid pipe or your for cold region 2, and for your solid region, your solid pipe 2. Okay. Again for inlet outlet, you can again use the face set command or the face set type, and you can specify your inlet and outlet. Again for container walls also you can use the face set. Okay. So over here there are some hints you can say. So over here you can see that for the left hand side you just have hot region, so you can just use face set, and wherever necessary you have to delete. So over here I have mentioned that you have to remove for inlet patch, you have to remove for outlet region, all of that thing. Okay, so just go through this, you'll be able to do it. Okay, it's not really difficult. So once you have done that, so let's go back to set fields. So as I said, set fields and toposet are similar to each other in terms of defining something or to set it up, but the applications are different for each of these. So for toposet, you will use it to define a geometry or to create a geometry within your domain or within a volume. Whereas set fields, you will define a zone, but you will initialize some boundary conditions within it. So it's usually used in multi-phase to define a particular zone as a fluid. So you can see that with this particular example. Okay, so we have a domain. In this, we have two fluids. So you learn more about this in your multi-phase tutorial. So again, I'll not go too much into multi-phase for now. I'll just briefly explain what exactly is happening with set fields. So you have a domain. In this, you have say fluid 1 and you have fluid 2. Now this is the typical dam break case. So we specify the fluid 2 to be water and fluid 1 to be air. Okay, so in blue it is air, in red it is water. Now, as I said, you can use set fields to define this particular region, or to define or to initialize these fluid regions. Okay, and it is widely used in multi-phase cases. So first you will define or you will create the fluid domain for the fluid 1, in this case air. So for this you can use block mesh. You will create a simple domain. Now this is the 2D domain. I've given the lower and upper limits for this case. So again, this is the 2D domain, so there's almost negligible depth in the Z direction. So you will create a domain using block mesh, and this will behave as your air of fluid 1. Okay, so now how do you define this fluid 1? So fluid 1 can be defined directly in your boundary conditions. So when you are specifying boundary conditions for multi-phase, you will have something known as alpha dot water. That is where you will specify the second fluid properties. But for the first fluid properties, you can just use the constant properties. So whatever you specify within constant, your domain will behave based on that. So if you were to specify constant properties of for fluid 1 as air, this entire domain will behave as air if you don't initialize anything. Okay. Now, the next thing that you will do is you will use set fields to define this second fluid region. Okay. So in this case, I've again given the lower and upper limits for this particular fluid region. Okay. You'll see why I've given you this region, these limits. Okay. So when you are creating, or you will open your set fields dict. So I'll open that. So this is your dam break case. So I've already run it. So under system, if you go down, you'll see set fields dict. Okay. So under set fields, you will have this particular syntax. Okay. Now this one is for 2412. It's the same for OpenFOAM 9 as well. So there's little to none change. Okay. So you'll have some default field values and you will have region. So this is the basic syntax you have to specify for setting up or to set a particular zone using set fields. Okay. So the very first syntax that you have to define your fluid, or the second fluid, in this case water, we want to define water. So we'll have the very first block that will be default field values. So under the default field values, whatever you specify over here, it will be applied to your entire domain by default. So that is what your default field values in simple terms means. So whatever values you specify here, your entire domain is going to behave according to that. Now over here we have volume scalar field value. So this indicates the type of field that is being set. And again, it is the volume scalar field defined to your at your cell centroids. So whatever cells are specified within this particular volume, it will behave according to that. Okay. Now in this case, that volume field value is alpha dot water. So in this case, alpha dot water is your volume fraction, and it is usually used in multi-phase cases. Again, you learn in depth about this when you are doing the multi-phase tutorial. And we then assign a value 0. Now in multi-phase, you have two values. It ranges between 0 and 1. So 0 being for air and 1 being for water. So now in this default field values, we have specified the entire domain to be 0, that is air. So anything by default set, or anything by default within this entire domain, will be air. Now we want to define the water region. So that is where your regions part will come into play. Okay. So for regions, now as I said, we had a bounding box. I gave you the lower and upper limits. So again, you can use the region part to define your fluid region that you want to specify. Okay. So this is where you will specify that fluid region, and then you will use the block, your box to cell. So again, this is the This is the syntax for putting in your bounding box. And over here again, you'll use the keyword box, and then you will type in your lower and upper limit. And then you will assign some field values to that bounding box. Okay. So now in this region, you have given a bounding box. You have given the lower and upper limit of that bounding box. Now you will specify the field values within this box. Okay. So again, the same volume scalar field value, you're just assigning the volume scalar fraction over your alpha dot water. And in this case, we have set it to 1, meaning that we want it to be water. Okay. So again, when you're learning multiphase, you'll learn something known as interface as well. So that ranges between 0 to 1. So that is known as the interface. But in this case, to keep it very simple, we are assigning that region to be water. Okay. So now by default, the entire domain was labeled as air, or is defined as air. And this particular region that we have specified using the bounding box is going to be water. Okay. So again, over here, it's not restricted to only one fluid. So over here, if you want to do a simulation with say 2 or 3 fluids, you can increase the number of boxes. Okay, so you can do box to cell. You have this particular limits that you have set. Then again, you can use box to cell. You can choose another limit, and within that, you can specify a different value. Okay, so you can see there's a tutorial also for multi-phase itself. But again, over here, since we're just using air and water, we'll keep it really simple. And I can show you this particular simulation, what we have ran. So this was the set fields. Okay, let's open this. Again, this is a very simple tutorial that is there in your uh, open form tutorials itself. So you can just download it, or you can copy it from there as well. So again, this was your alpha dot water. Okay. Hmm. So as I said, if you were to just do block mesh and run the simulation, it would just show you the entire domain to be set as air. Whereas if you now, since we are using set fields, we have defined this particular zone as water. Okay. So you can see the simulation, how does it progress? So once you are running with the simulation, now this particular thing is set so that your this water column will break and it sloshes around. So that is your typical dam break case. Okay. So again, you can change this value based on whatever you want. So this is a way in which you can define your set fields. Okay. And now another thing that I did not talk about was the create patch field. Okay, the create patch dict. So let's open this one. Hmm. So under the create patch, this is where you can assign a patch to your to a zone that you have defined using topoSet. Okay. So over here under the patch, under the create patch dict, you will have patches, and then you will have the name. Okay. So over here you can again, once I share this file, everything is written within this file itself. So you have the name of the new patch that you want to set. So name over here, I want it to be inlet hot. So this is the same name that will show up in my paraview once I do create patch. Okay. So I have to just type in the terminal create patch, and it will run that particular dict. Okay. So again, the patch info is type set, construction type set, and then for set you want to use phase set, and also you can set IH. So it will access that IH that we had used, or it will label it as IH accordingly. Okay, so this hot inlet or whatever you specify over here. So these names have to be linked with your topo set. Okay, that way then you can assign some boundary conditions to these. So again, over here for container walls, we have specified the patch set, and we have set the name container walls. So once you do create patch, it will show up over there in your paraview under these names. Okay. For now, if you see, if I were to do just do paraview, it shows me as cell zones and cells and all that. But once you do the create patch, it will unify everything together, and you'll only have your patch names at the end. Okay. So this was it about uh, toposet and create patch fields. Again, over here, this is your assignment. So you have to complete that toposet dict file that I will be sharing. You have to complete that for both cold regions and both the pipe regions. along with the heated inlet and outlet. Then you also have to define the container walls using the same approach that you use for your heated inlet and outlet faces. And you can then use this particular PPT as a reference for the syntax or whatever values you want to choose for those regions. Okay. Again, the same thing, you can search all of these commands. So say you want to search for action. So under your form tutorials, you want to find, say for action or source, you want to find what are the available source types that are there. So you can type action, then you can type source, and under topoSet dict, it will search what are the available types. Okay. Or you can also go by keywords. So if you want to just type source, you can just type in grep-r, and you can type, instead of set fields, you can change it to source or source types. It will give you some results. Okay. And these are some of the useful links that I have shared. So over here you have the open form documentation for topoSet, and you also have the open form documentation for set fields. And these are the user manuals that you have. So you can open the topoSet documentation that we have. So under the documentation, you can see they've given the basic syntax of how exactly you're supposed to define things within your topoSet dict. Along with that, they have also given how can you define these operation types. So you have point set. Now over here we used face set and we use cell set. You also have for zones the same thing. Again, as I said, for source type you have add, subtract, new, subtract, subset, clear, remove. So there are multiple options. You can read through this. There are multiple options as well for box to face, cell to face. Now over here we use cylinder annulus. You can also use hole to face. You can also use label to face. So there are multiple options for that. Okay. Same goes for the zone, phase zone types and your cell set types. Okay. So this was it about topoSet and set fields. Again, you can go through this PPT. If you have any doubts, you can always ask me in the next session, and make sure you complete that assignment by the next class, because then if you're not able to do it, I will share the solution deck in the next class itself then. But try to run topoSet or try to do topoSet using this syntax and this PPT as a reference, because if you don't try it yourself, you won't learn anything. Okay, because topoSet and openform is something that you will only learn once you start doing something in it. If by us just giving you a PPT and explaining things to you, and if you don't do it on your end, it's of no use. You just have some basic knowledge, but you won't be able to apply that knowledge. So again, try using topoSet, try using set fields. Again, set fields will be used in the next tutorial under multi-phase. So it will be really crucial when you're dealing with multi-phase simulations. Okay.